All right, let's talk section 2 now. Section 2 is quite a bit longer than section 1, so we're going to be at this for a little while. So let's talk about air pollution in a little more detail. So what is air pollution? Well, it's the presence of any chemicals in the air that are concentrated and high enough to basically hurt or cause harm. So we can't restrict that to any one particular. It's not just a chemical. It can be particulate matter, it can be biologicals, it can be other things too. So the presence of chemicals is a little restricting for us. So natural sources: dust blown in the wind, pollutants from forest fires and volcanoes, and then volatile stuff from plants. Those are the only three natural sources for the most part of air pollution. Human sources then are a little more diverse in the quantities of them, and they come from two different places: stationary sources and mobile sources. And they are exactly what you think. Stationary sources, power plants and factories, where the thing doesn't move, and mobile sources like motorized vehicles and farm equipment, where the thing's in constant motion. When it comes to pollution, we also have two types of pollutant. We have what we call primary pollutants, and then we have what we call secondary pollutants. Primary pollutants are substances that are emitted directly into the air. So the stuff that comes right out of your tailpipe, for instance, is a primary pollutant. A secondary pollutant is when primary pollutants go up in the air and they form chemical reactions in the air, and then that chemical reaction forms these new chemicals. The new chemicals are secondary pollutants. And so what are some major outdoor air pollutants? Well, carbon oxides are one of the major ones. So that involves carbon monoxide and carbon dioxide. Carbon monoxide is extremely poisonous, toxic thing, and it happens when we burn carbon-based things and we don't get a complete burn. It comes from incomplete combustion. So when you burn something, it's really kind of smoky and kind of gross. Typically, you're getting an incomplete combustion, and carbon monoxide is forming in that case. It doesn't form in as much quantities as carbon dioxide. That is a major part of the carbon cycle, of course, and when you burn stuff, it is one of the main things that's produced, that in water. And so 93% of the carbon dioxide in the atmosphere is down in the troposphere, and it's part of the carbon cycle. And then 7% is a result of human activity. So not a very big proportion of the CO2 is human-based. A lot of it's just there and at work naturally. But nonetheless, we've increased that quite a bit. And this is not a pollutant that's regulated by the U.S. Clean Air Act. So there are many pollutants that we have to keep the air clean, but CO2 is not one of those. Next, nitrogen oxides and nitric acids. So these are also a problem. These also happen when we burn things. They naturally occur within plants, for instance, animals, and fossil fuels, and when we burn those, we release them into the air. They can be produced other places, like in lightning storms or by soil bacteria, and so they are a natural organic-based thing. The NO reacts with the oxygen in the air, and it forms NO2. That NO2 can then react with water and produce nitric acid, and that nitric acid basically makes acid rain. And so this is a problem for a variety of reasons, but it does cause acid rain. And so in addition to that, both NO and NO2 are also involved in formation or making of smog. Sulfur oxides, again, similar situation, and sulfuric acid to our nitrogen situation. So there's a lot of SO2 that occurs naturally and is part of the sulfur cycle. But there's quite a big chunk. 2/3 of it actually comes from human sources. So when we burn coal, one of the elements that's inside of coal, especially dirty coal, is iron sulfide. Iron sulfide, when it gets smelted or burned with oxygen, produces iron oxide and SO2. And that SO2 then can go up in the air and react with water and make sulfuric acid and be another component of acid rain. Suspended particulate matter. So particulate matter are very small, fine particles that are suspended in the air, like dust, soot, things of that nature. So there are natural sources of that. For instance, forest fires and volcanoes and dust storms all create those. And then there are many different human sources. combustion is one of those. So they're very fine particles, and they actually range in size. The most harmful ones are the very fine ones that get up to below 10 micrometers in size. If you get below that, then we start having health issues, and ultrafine ones have any more than that. They actually can go and get lodged in your lungs, stop your capillary action between your lungs and your bloodstream from working properly, so we don't get oxygen transfer between the two. So, a bigger issue than one might think. Ozone. Ozone, good if it's in the stratosphere, creates the ozone layer and protects us from UV radiation. On ground level, though, ozone is bad, and it's a major component of several things. It's a part of photochemical smog, and then it also creates rot and issues with other things like rubber. It's an unhealthy thing to have in any other location. Down at ground level, solar radiation actually splits an O off of NO2, and that bonds with O, creating your O3. So when you look at photochemical smog like in Denver, you're seeing a lot of ozone right there in that level. Next, VOCs, volatile organic compounds. These are compounds that are vaporized or go into the air really easily. So if you have a really pungent smelling cleaner or something like that, it probably has VOCs in it. And so they're used in household cleaners and disinfectants and paints and fuels. But there are also other industrial solvents like trichloroethene and benzene and vinyl chloride. All of these things are organic solvents, and they all are organic compounds that can create problems. How do we detect these bad boys? Well, chemical instruments can be used, like we send aircraft up in the atmosphere and gauge them. We have air pollution monitoring stations that gauge how much air pollution that we have. And we also have biological indicators, like this picture over here of lichens. Lichens are a small creature that can be really sensitive to air pollution. And the cool thing is, certain ones are sensitive to certain air pollutants. So it might be specifically SO2 that makes certain ones suffer. And so you get a really good indication. Peppered moths, which you learn about back in biology, could be indications of soot. And you've already learned about that, so we won't go into great detail on that one. So, industrial smog. So there's two flavors of smog. Industrial smog is one of those. And it's basically a mixture of sulfur dioxide, droplets of sulfuric acid, and suspended particulate matter from the burning of coal, for instance. So when you look at this picture over here on the left, you see how brown and it is. Okay, that's basically what the sky in like London during the Industrial Revolution looked like. It was full of industrial smog. Third world countries also suffer a lot of industrial smog. In the United States, we have a lot of regulations that clean up industrial smog before it becomes a problem. And the reason why we have a lot of good pollution controls in our smokestacks. So when you see a smokestack around here, this is what you see, that nice tailing of smoke there that kind of goes away, as opposed to this, which means that we're doing a lot of regulation to not allow the industrial smog up into the atmosphere, and we're instead containing it in other locations. So how do pollutants form industrial smog? Pretty close. You're going to burn coal and oil. So you're taking your sulfur and your carbon, you're combining with oxygen, producing carbon monoxide and carbon dioxides, and sulfur dioxides, which then can combine with oxygen, producing sulfur trioxide, which combines with water, making sulfuric acid. Sulfuric acid can also interact with ammonia, creating ammonium sulfates. All of these are components of industrial smog. This industrial smog is a real problem in third world countries, especially big ones like China and India. And so this picture down here shows a group of people walking in Beijing, and you can see the level of industrial smog that they're dealing with. It's actually so bad that you can actually look at, this is a satellite image of the Asian peninsula, and you see that there's this brown, nasty brown cloud that hovers over top of it all the time as a result of industrial smog. And so it is an issue, and they're working to clean that area up in many different ways. But population booms in India and China, it's been a struggle. What's the problem with it? Well, it doesn't allow photosynthesis to reach the surface of the earth, creating all kinds of problems for crop development, not to mention crops are absorbing that stuff too. And then those fine particulates and droplets in the clouds are altering weather patterns in those areas. And so we're monitoring to see how bad that's going to be, or what we can do to fix those problems. Next is photochemical smog. Photochemical smog is made due to a reaction with light in the sky. So here is a picture. This is in Asia, and here's a picture from the same location after the smog is hit. So if you have VOCs in the atmosphere, and you have nitrogen oxides in the atmosphere, and you place them under heat and sunlight, what it will result in is the development of photochemical smog. The reaction creates, well, can mix with water in there as well, breaks these chemicals down and alters them, and then it creates all of these other potential chemicals. Ground level ozone and photochemical oxidants and aldehydes and other secondary air pollutants. So photochemical smog is very common, especially in sunny areas. It can be a real issue. So what are the worst smog cities? Well, Mexico City is the worst. And one of the reasons why it's the worst is it's huge in size, and its geological location creates some problems for it. And so we'll talk about that moving forward. Beijing, China, and New Delhi, India are both real problems due to the size of the people. Cairo, Egypt, Bangkok, Hong Kong, and then 2 in the United States, Houston, Texas, and LA. Both receive a lot of sun, and they both have populations of 5+ million people. And so the combination of that results in quite a bit of smog between the 2 locations. How do we decrease it? Well, we can decrease it in one of a couple ways. We can allow for the settling of particles, and that can be due to gravity and precipitation and sea spray and winds and chemical reactions. So there's lots of ways to do it with those things. And rain washes out the sky all the time, for instance, and gravity if the particles are, and we can put chemical reactions into place to create that process and exacerbate the process. And so that's one way to do it. Ways that it's increased, urban building. They mess with the wind dispersal and all that kind of stuff. Hills and mountains create problems, excluding temperature inversions, which we'll talk about next. And then high temperatures create photochemical reactions, and all of these can create worse problems for pollution in the air. So temperature inversions. Temperature inversion is where the temperature changes. So you can see a decreasing amount of temperature, all of a sudden there's a spike in the temperature before it decreases again. That is your temperature inversion right there. And what it does is it alters the way air moves and whether it can get trapped. And thermal inversions often create what we call a capping of the atmosphere. They don't allow anything to move above them. So you have this descending air pocket. You might have a sea breeze going sideways up against these mountains. And then as a result, we don't get any movement here. And so Mexico City is a good example of this. Typically, hot air rises up to colder spots and all the pollution will go away. With a temperature inversion in there, that it's forced to be stuck in that location and not be able to leave. And so you'll see temperature inversions. They're pretty common. If you have a fire or something and you get that flat line, the temperature inversion's right here and it's not allowing it to get any higher. Mexico City sits in a valley between 2 sets of mountains, and there's usually temperature inversions over top of it, and so the smog stays trapped in there, and that's why Mexico City is one of the worst smog areas on the planet. And then we can create what we call heat islands. This is a place where we have lost all the vegetation in a specific area. Urban heat islands are very common. So there's no vegetation to absorb the light and regulate the heat, and so these places get extremely hot. And so as a result, we call them urban heat islands. And so temperature anywhere between 2 and 10 degrees hotter can create some real problems. And so you have increased likelihood of temperature inversions and then increased likelihood of air pollution and smog building up in those locations as a result. All right, that's the end of section 2. Peace and love. Bye-bye.